All right, welcome back. We're going to do a little bit more advanced polynomial arithmetic. We're going to add these two polynomials. First thing you can notice here is that we have a trinomial, 1, 2, 3 monomials that are added or subtracted. And then we have another trinomial, 1, 2, 3 monomials. Now, notice that in this trinomial we've got x to the fourth for one of our terms, x to the third. We have no x squareds, we have no x to the first, and we have one constant, which is 7, which could be considered 7 times x to the 0. Then this trinomial has an x to the third, but it has no x to the fourth. It has an x squared, it doesn't have an x to the first, and it does have an x to the 0, or a whole, -9 in this case. Okay, so when we go to add, when we do normal numbers like you've seen before, say 234 plus 57, if we were going to add these, we would normally, traditionally line them up in place value columns like this, 234 plus 57, and we'd add in place values. Now notice, this number 57 had no hundreds, so I just didn't write it. But I could have written a 0. We don't normally, but when we go to do the polynomial addition, we're going to see why that's important. Or, take another example. What if we were going to add 234 plus 1003? Okay, we'd line those up. A lot of times you would put the bigger one first. It doesn't really matter though. So let's say 234 plus 1003. Again, we could put a 0 here. We need these zeros. We didn't have to have that one in our traditional addition problem because it was the first place value. So if nothing appears there, we understand that means 0. But these zeros matter. If I take the zeros out and condense this, it becomes the number 13, which isn't 1003. So it's important that we actually indicate what place values have no value in that place value with these zeros. Now we're going to do that same thing with our polynomial addition. Let's see how that works. So we'll put our highest term first, 6 times x to the fourth. X to the fourth is our greatest monomial. The index is the highest. The exponent is 4. Okay, and then we have negative 2x cubed. This polynomial has no x squareds. We want to write that because we need it like a place value. Okay, so we have 0 x squareds. We have 0 x's, x to the first, and we have 7 times x to the 0, or 1. So those are wholes. Now, we're going to do the same thing here. We have no x to the fourth, so we don't have to write that. We could, but we don't have to. It's the first highest place value. First term we come to is 5x cubed, so we're going to put that right here in the x cubed column. This is like a place value. Then, x squareds are next, so we have 4x squareds. Then we have no x's, no x to the first, and we have negative 9 times x to the 0. Now, we're set up with a great big addition problem. We're going to add these, all right? We've got 7 wholes minus 9 wholes, that's negative 2. We've got 0 x's, so we'll put that in, 0 x's. We have 0 x squareds plus 4x squareds, that's 4x squared. We've got negative 2x cubes plus 5x cubes, that's positive 3x cubes. And we have 6x to the fourth with nothing being added to it, so 6x to the fourth. All right, here's our new polynomial that we get when we add these. Now, we don't need to write 0 x's, so we're going to simplify that and say that this equals 6x to the 4th plus 3x cubed plus 4x squared minus 2, and we're done. There's our answer right here.